Containerization is a method of packaging and deploying software applications in a way that makes them easy to run and manage, regardless of the environment they are deployed in. Containers allow developers to package an application, along with all of its dependencies and libraries, into a single container image. This image can then be run on any system that has a container runtime installed, such as Docker or Kubernetes. The main advantage of containerization is that it allows applications to be deployed and run consistently across different environments, including development, staging, and production. This makes it easier to manage the application lifecycle and reduce the risk of issues arising from differences in the environments. Containers are also lightweight and efficient, as they share the host operating system's kernel and only include the libraries and dependencies required by the application. This makes it possible to run multiple containers on a single host and makes it easier to scale applications horizontally by adding more containers. Overall, containerization is a powerful tool for simplifying the deployment and management of software applications and is widely used in modern software development practices. There are several ways to do containerization, and the most common method is to use a containerization platform such as Docker or Kubernetes. Docker is a containerization platform that allows developers to build, ship, and run applications in containers. It provides a set of tools and services for building, distributing, and running containers, including the Docker engine, which is the runtime that manages the containers, and the Docker Hub, which is a cloud-based registry for storing and sharing container images. Kubernetes is an open-source container orchestration platform that allows developers to deploy and manage containerized applications at scale. It provides a set of APIs and tools for deploying, scaling, and managing containers, including features such as self-healing, load balancing, and rollback capabilities. In addition to these platforms, there are also several other ways to do containerization, such as operating system-level virtualization. This is a method of running multiple isolated operating system instances on a single host, each with its own resources and libraries. Examples of operating system-level virtualization technologies include Linux containers, LXC, and OpenVZ. Virtual machines, VMs, allow developers to run multiple operating systems on a single physical machine, each with its own resources and libraries. VMs are typically used for running different applications or operating systems that are incompatible with each other. Serverless computing. Serverless computing is a model of computing that allows developers to build and run applications and services without the need to manage infrastructure. Functions or services are executed in response to events or triggers, and the infrastructure required to run them is automatically provisioned and scaled by the provider. Serverless computing platforms, such as AWS Lambda and Azure Functions, allow developers to deploy their applications as containers or package them as functions. Overall, the choice of containerization method will depend on the specific needs and requirements of the application being developed,